Hi, this is Shring Siddharth and welcome to my course. In this one single course, I will teach you everything you need to know about coroutines in Kotlin. This is going to be a 2-hour course. So for simplicity, I have divided this course into 5 different chapters so that you can easily follow along with the course. And these chapters are designed in such a way that you will start from building your foundation and end up mastering a particular topic. So in the first chapter, you will learn all the basics and foundation of coroutines in Kotlin, such as what exactly is a coroutine, how can you create them, what are coroutine builders such as launch, async and runBlocking functions, what are suspending functions, and how coroutines are exactly different from threads. Fine. So once you build your foundation in chapter 1, we will move on to the next chapter. That is our chapter number 2. In this chapter, we will dive into coroutine builders, the basics of which we already explored in the previous chapter. So in this chapter, we will dive a little deeper into each coroutine builder. And in the same chapter, we will write our first test case using coroutine. Next, we have chapter number 3. So in this chapter, we will start to see the intermediate level concepts. So once we have built the foundation, we will raise our level, right? So this chapter is basically based on coroutine cancellation and also exception handling. Then we will move on to our chapter number 4, where we will continue to see the intermediate level concepts. So in this chapter, we will learn how to compose suspending functions, such as how to execute them sequentially, how to execute them concurrently, and even lazily. Then after this chapter comes the last and final chapter, that is chapter number 5, where we will increase our level from intermediate to little advanced concepts of coroutines. So in this chapter, we will learn the core concepts of coroutines such as CoroutineScope, CoroutineContext and dispatchers. Now these 3 topics are very crucial if you want to use coroutines in your application. And at times, they might be very confusing while using them in your app. So this final chapter will give you more insight into the world of coroutine. So make sure you don't skip this chapter. To make things clear and precise in this course, each topic is explained by using beautiful slides. And of course, also explained using appropriate demos. So make sure you follow each of the demo step by step along with me so that you can make the most out of this course. And for your convenience, each demo source code has been uploaded to GitHub. So you can reference them anytime you want to. And of course, before we start this video, if you are new, please subscribe to my channel and give this video a big thumbs up. This is Shring Siddharth and let's start this course. So let us start with our first chapter and understand the basics of coroutine and what exactly is a coroutine in Kotlin and how can you use it in your application.
So firstly, what are coroutines and what is it used for? Well, to understand what are coroutines, you would need to first understand how exactly your application works when the user launches your application. So when the user launches the application, a default thread is created, and this thread is known as the main thread. Now this main thread is the life of the application. Let us represent the main thread with the help of this blue arrow. So what is the purpose of having the main thread? Well, the purpose of having the main thread is to perform some operations. And these operations are very small and lightweight operations, such as the UI interactions, click of the button, mathematical operations, or lightweight logical operations. So basically on the main thread, we perform small operations. Now, what about the long and heavy operations, such as that requires the use of internet, or upload or download of a file from the server, loading and displaying an image from the server, or running some heavy database queries. Well, if you run these heavy operations on the same main thread, then in that case, your main thread will be blocked. And when your main thread gets blocked, then your application will freeze. In simple words, your application will get hanged. And in case if your main thread remains blocked for a longer time, such as 5 seconds or something, then eventually your application will shut down with a crash message. And I am sure while using any application, you must have experienced such things where your phone becomes slow and your application crashes, right? So, running such heavy operations on the main thread is indeed a bad idea. To counter this situation, we have a solution. Instead of using the main thread, we can create a worker thread or the background thread. And on this worker thread, which is also known as the background thread, we can run heavy operations, such as we can create a thread to perform some network operations. We can create another background thread to download or upload a file. Similarly, we can launch more background threads to load images or to perform some heavy database operations. So in general, you always create a new thread to perform some heavy operations, and that would make your main thread available for other small operations. So this is how actually your application works, right? Now, these background threads sounds like a solution, but there is a limit of how many background threads you can create at a time in your application, because creating threads is very expensive. And if you create more and more threads, then there would be a time when your device will run out of memory. And eventually, once again, your application will shut down with a crash message. Hence, creating so many background threads is also not a good solution. It's a bad idea. So what is the next solution? Well, here comes coroutines into the picture and to the rescue. So, when you use coroutines, then you don't have to create so many threads for each operation. Instead, you can just have one background thread, and on this background thread, you can launch coroutines, such as launch a coroutine to perform file upload operation, launch another coroutine on the same background thread to perform some network operations. Similarly, launch one more coroutine to download a file. Similarly, we can have more coroutines to perform other operations like this. In short, with the memory consumption of one background thread, you can perform so many heavy operations. How cool is that? So this is what coroutine does. Nice and simple. So I hope now you got an idea of where does a coroutine fits in your application. Fine. So now, moving ahead, how do we define a coroutine? Well, you can think of coroutine as lightweight threads. Similar to threads, coroutines can run in parallel, wait for each other to finish, and even multiple coroutines can communicate with each other. But remember, coroutines are not threads. So please note this. This is very important. Their functionality might look similar, but they are totally different. They are not same. And the biggest difference of a coroutine when compared to a thread is that coroutines are very cheap. They are almost free. We can create millions of coroutines at a time, and we don't have to worry about the memory consumption. Your application will run as smooth as you can imagine. So that's not possible in case of threads, right? You cannot create thousands of threads at a time. So for modern applications, coroutines are indeed the modern solution. Don't you think this is awesome? Well, of course it is. That's why coroutines are trending today, and that's why you are here to learn about it. So now, how to use coroutines? Well, to use coroutines, we would need a Kotlin project, right? So let's create a new project in IntelliJ IDE. So let's create a new project and from left select Gradle. At the top it will show you the project SDK, which is default JDK available in your system. From here select Kotlin JVM. Make sure only this is selected. Fine. Then click on Next. Provide the project name Kotlin Coroutines. Then do nothing, just click on Finish. While creating a new project, make sure you have active internet connection, otherwise it won't work. And creating a new project might take a little time, so please have patience. So once your project is created, you will get your build.gradle file right in front of you. If you don't see it here, then from your project, navigate to build.gradle file. And within this file, within dependencies, just add this statement. Well, this statement will integrate Kotlin coroutines in your project. And since coroutine library is published to the JCentral repository, so within repositories, just add this statement, like this. And then here at the top, you will find this icon. Load Gradle changes. Let's click on it. This will integrate coroutines and apply the changes to your project. So once you are done, navigate to the main folder, navigate to Kotlin, and within this folder, let's create a new Kotlin file. Let's name it Kotlin Coroutines itself. Select File, Create. Let's minimize the Project Explorer, and here let's create a main function. Now, this main function actually operates on the main thread, which we just saw in our slide. And if you write some code within this main function, such as a few print statements, like this, then these two print statements will also execute in the main thread, because they are being called from the scope of main function, which is running on the main thread, right? To prove my point, I am going to print the thread name, like this. Let's run our program. So here we go, we are indeed operating on the main thread. Perfect. Now, let us create a background thread in place of this statement. By using thread lambda expression, just select the first one. So this thread function is going to create a background thread for us, which is also known as a worker thread. And within this thread, let us perform something. Let's add a print statement first. And also, we will verify on which thread this code will be executed. And after this print statement, let us pretend to do some work. So this will do some work for approximately 1000 milliseconds, which is 1 second. Well, in real projects, you would need to replace this statement by some real task, right? So don't use this Thread.sleep statement in the real projects. Instead, you can write some code for upload or download of a file, right? This is just a dummy fake work. And right after this, let us print fake work finished, like this. So I hope this code makes sense to you now. Let's run the program. So here is the output. So here our main program started in the main thread and ended in the main thread, which you can see in the output, right? And the code that belonged to the thread executed in some other thread, which is actually the background thread. Fine. So how exactly our program was executed? Well, firstly, from the output, you can observe that these two code were executed independent of each other. They both started and ended in their own way. So this statement, which is the print statement over here, first produces this output. And then in sequence, when this thread lambda expression was executed, then it launches a new thread in the background to do these works. So this background thread did not block the code of the main thread, which also means that now these two threads are running in parallel. Hence, immediately after this statement was executed, the code within the main thread resumes. So this statement will not wait for this background thread to finish its work, because they both are running in parallel, that is, concurrently. So immediately after the main program starts, you get main program ends in the output console. And now, since the background thread was running in parallel, therefore the code here within the thread once starts to execute produces output accordingly, such as fake work starts and finish. Perfect. So what I want to say is that the code in the background thread did not block the code of the main thread. They ran in parallel, that is, in concurrent manner. Quite simple, isn't it? And also, if you run the program again, then you will find that there was a gap of 1 second between these two statements. It is due to our fake work going on at this line of code that lasts for 1 second. Fine. Now moving on, here I want you to note one more thing. Even after the last statement in the main function was executed, then also the application waited for our background thread to execute and complete. And only after these three statements were executed, our application ended. For which you can find a statement here, process finished with exit code 0, which means our application ended. So just note that in case of threads, the application waits for all the background threads to complete. So only after the code within the thread were executed completely, then only our application ended. Right? So please note this, what happens in case of thread. I will come back to this point shortly when we will discuss coroutines. Now moving on, let us replace this thread by a coroutine. So I will use GlobalScope in camel case and select this one, KotlinX.coroutines.launch function, this one. So once you do it, you will find these two imports. Even you can trim it down to like this using a star at the end and remove this import of thread. Great. So this launch function, what it does, it basically creates a background coroutine that runs on a background thread. And we can check on which background thread the coroutine is operating using this function. Great. And here we are again pretending to do some fake work. And after the work completes, we print fake work finished along with the thread name. So let's run our application. So here our main program started and ended, and our application also finished with exit code 0. But there are no signs of the output which belongs to this code over here. So what's wrong in our program and why our coroutine code were not printed in the output console? Well, just now I showed you that in case of thread, if you use thread here, then the main function is going to wait for the background thread to finish their work, right? But in case of a coroutine, things are a bit different. When a coroutine is launched, the application by default do not know it has to wait for the coroutine to end its work. So this is another difference between while using a thread and while using a coroutine. Now the question arises, how can we make our main function to wait for our coroutine to get its work done? Well, for this we need to manually make our application wait for the coroutine to finish its work. So right here you can add Thread.sleep and use 2000 milliseconds. which is actually 2 seconds. If you run the application now, you will find that our program right now worked perfectly fine this time. And also, for these two print statements, you will find we are not operating on the main thread. The name of the thread is something which belongs to the background, that is, other than the main thread. So now, how this statement has made our program to work? Well, this statement, what it basically blocks the current main thread and wait for the coroutine to finish. So that is why here I have used 2 seconds in the parameter, which is greater than this 1 second over here. Fine. So this delay of 2 seconds will wait for this coroutine to get its job done. And then right after waiting 2 seconds, the main program ends and our application ends, right? So yes, this is how we create a coroutine, do some dummy work, and make our main function to wait for the dummy work to finish. Now here you might ask a practical question. Suppose if our real job is to upload a file to the server, for which you need to write code in place of this statement over here, then in that case, practically it would be impossible to know how much time it will take for the file to get uploaded. In short, we won't know what time we need to fill here within the Thread.sleep function so that we can wait for the coroutine to finish, right? Which means practically this statement is useless for the real projects. So in the real projects, what exactly we need to write in place of this statement so that we can wait for the coroutine to get its job done? Well, for the answer, you need to wait a little bit. Right now my intention was to just show you how to write your first program using coroutine. So wait a little bit, follow my coroutine videos, and you will definitely get your answer at right time. That's my promise. Perfect. So let's get a quick summary of what we saw just now. So we create a thread using this lambda expression in Kotlin, and we delayed the thread or pretended that we are doing some job by using this Thread.sleep function. And then we saw how to create a coroutine which is attached to a thread by using this syntax. But we used the same Thread.sleep function within our coroutine as well. Now this Thread.sleep basically blocks the entire thread. So if some other coroutine are operating within the same thread as this coroutine is operating, then it will basically block that other coroutine as well, which is not good, right? And it basically violates the principle of using coroutine. So what is the solution to this? So instead of this Thread.sleep, you can use the delay function, which again takes time in milliseconds. So this delay, when executed, does not block the thread on which it is operating. Let me elaborate it and show you how delay function is more efficient than Thread.sleep function. So here, when this code is executed, a thread is created. But when Thread.sleep function is executed, then for 1 second, your thread will be completely blocked. Meaning, for this time frame, your thread won't be able to do other tasks. It gets busy, right? Now, let us come to our coroutine code. So when this code is executed, it creates a coroutine that is attached to a thread. For clarity, let's name the coroutine as C1. And of course, there could be other coroutines that are operating on the same thread. I guess no doubt till now, because we can have multiple coroutines on the same background thread. Now, when this statement delay 1000 is executed, then it basically suspends the coroutine for 1 second. But it does not block the thread at all, which means the execution of other coroutines are not at all affected. They keep operating in the normal manner. So I hope this clearly shows you the differences between the delay function and Thread.sleep function. So here in our program, let us replace this function by delay function. Now moving on, I want to talk a little bit more about this delay function. How does it work? So let us start from the beginning. So when we launch a coroutine, then let us assume our coroutine starts on thread named T1. Let us assume that. So the next statement which will be executed will of course execute on thread T1, right? But when this delay function is executed, then it basically suspends the coroutine or pauses the coroutine. And in that case, the thread T1 becomes free, meaning the thread T1 is firstly not blocked and it can associate with other coroutines to perform some other task which we saw in the slides, right? But after delaying for 1 second, when this print statement executes, then what do you think? On which thread this statement will be executed? Well, here is a little twist. It is not necessary that this statement will be executed in the same thread T1. It could be thread T1 or it could be some other thread, maybe T2 or T3. So let us run the program. So here you can see that it is just a coincidence that this fake work finished statement was executed in the same thread as it was executed for the previous statement in the same coroutine, right? But it doesn't mean that this thread will always be same for both these statements. It can definitely change if we run program in future. Now, this changing of the thread concept is not only applicable for the code written after the delay function. So on the left here you will find a symbol. It says suspend function call. Well, what is a suspend function? I will come to this shortly. But in place of delay, if we have some other suspend function as well, then also this changing of thread is applicable in that case as well. So please note this. Now right after our coroutine within the main function, we have again Thread.sleep. Let us replace it again by a delay function. And here the compiler is not happy. Let's see what's the error. It says you cannot call the suspending function from outside a coroutine. So what does that mean? For that, let's see the definition of this delay function in the documentation. Well, the delay function is of the type of suspend. This is a special modifier found in Kotlin. So this creates a new question for us, such as what is a suspend modifier and what are suspending functions? Well, you can define suspending function as a function with a suspend modifier is basically known as suspending function. And the suspending functions are only allowed to be called from inside a coroutine or from another suspending function. In short, you cannot call the suspending function from outside a coroutine. So this is the reason why the compiler was complaining us. So please remember these 3 points. These are very basic but very important things to remember while dealing with coroutines. So now we know that this delay function is a suspending function, which means you cannot call delay from outside a coroutine. So how can we call a delay function over here? Well, the solution is to wrap the delay function within runBlocking lambda expression. Like this. Run the program again. So here the output remains the same. So this runBlocking function, what it does, it basically creates a new coroutine, but this time the coroutine blocks the current thread, which is the main thread in our case. So when you launch a coroutine using runBlocking function, then it basically blocks the thread in which it is operating. So in our case, runBlocking is going to block the main thread. And then calling the delay function will wait for our previous coroutine to finish its task. Right? So what we were able to achieve using Thread.sleep function, we are achieving that now by using these 2 lines of code. But again, this is still not exactly the right way to wait for other coroutine to finish the work. Well, what is the right way to wait for other coroutine to finish? We will check it little later, not right now. For now, just focus on the concept that I am teaching, because we have just started with the topic of coroutines. Now moving on, also note that these two functions creates a new coroutine, right, that runs in parallel. But these two functions are completely different. This launch function creates a coroutine that does not block the main thread or the thread in which it is operating. But this runBlocking function creates a coroutine that blocks the main thread. So right now just remember this small difference between them. We will discuss more about them later. Now moving on, you can present the entire code in a little different way. Suppose if you wrap this entire main function within runBlocking lambda expression like this and remove this runBlocking from here and run the program again, then in that case the output remains the same. Fine, so what changes I have just done? If you analyze the code in sequence, then this main function starts to execute in the main thread. Then, using runBlocking, we launch a new coroutine that blocks the main thread, meaning this coroutine runs on the main thread. Then this print statement will run on the main thread, because this print statement lies within the scope of runBlocking method that is running on the main thread. So please note that. But when this launch function is executed, it creates a child coroutine, but in a background thread, meaning this entire code starts executing parallelly in concurrent manner in the background. Let us assume the thread is T1. Now, this delay function is actually present within the scope of runBlocking function. So this code is going to execute on the main thread. Fine. And then finally, this print statement will again execute on the main thread. So I hope things are now clear. Why wrapping the delay function using the runBlocking is exactly similar to that of using runBlocking in the entire code, like this. Now, while dealing with coroutines, it is very important for you to keep track of the threads that are being used. So that is why right from the beginning of this video, I am emphasizing on the thread being used at each and every line of code. And trust me, if you are clear with the basics, then this topic of coroutine will become very easy for you. Fine. Now, you can further write this entire same code in more optimized way. You can make this main function as a function expression and use runBlocking here. And what you can do is, you can just remove runBlocking from here and remove this curly bracket. Great. So this entire main function will create a new coroutine. Well, it is the way we write code in Kotlin, but don't worry, the output remains the same. Perfect. Now moving on, let's come back to the topic of suspending function. We actually got deviated from this topic to explore runBlocking. So you can also create your own suspending functions as well. For that, all you have to do is you can use the suspend modifier, give function name and define parameters like you usually do. Then you can write your own code further. For example, I will call a delay function and provide the time which I am receiving here as parameter. Like this. And then you can call this suspend function from within the coroutine, like from here and also here. It is going to execute my suspend function and pass 2000 millisecond as a parameter, which will further call the delay function. So I guess no doubt till now, and the output of course remains the same. Fine. You can run the program yourself and verify the result. If you are feeling jumbled at this point of time, then let us summarize and get a big picture of what we have covered so far in this video. At this point of time, we now know what are coroutines and how they are different from threads. We then learned how to set up a Kotlin project and add coroutine dependency by using Gradle. Then we saw what are suspending functions and how to create such functions on our own. Then we also saw two ways to create coroutines. First by using launch function and another by using runBlocking function. We also explored the basic differences between them. I hope you remember that. And above all, we always explored on which thread your coroutine is operating. Well, remember, if you are able to keep track of threads while using coroutine, then you can very easily write complex code using coroutine in your application. And in case if you have any confusion regarding threads while using coroutine, then you must watch this video once again. There is no harm in that. And if you are curious to know what is the exact way to wait for the coroutine to finish, or if you want to know more about runBlocking function and its right usage,
then you must watch chapter 2 of this course. So, congratulations on completing the first chapter. I am sure you enjoyed it. So, without wasting any time, let's jump on to our next chapter. That is chapter number 2. So, again, this is Shreng Siddharth, and I welcome you all to the next chapter of this course. In this chapter, you will learn in detail about
coroutine builders in Kotlin. Now, coroutine builders are basically a few functions such as launch and runBlocking functions. And from the previous video, we already got a basic idea about them. So in this video, we will dive deeper and explore them in detail. Great. So now, what exactly are coroutine builders? Well, as the name implies, coroutine builders are nothing but the functions using which we create a coroutine. As simple as that. So, what are the different types of coroutine builders? Well, the first is the most commonly used one, that is the launch function. The second is the async function, and the third is the runBlocking function. Now, apart from these three, there are other ways to create a coroutine as well, but these are the most important ones, so please note this. Now, in case of launch function, we also have something called GlobalScope.launch. Well, this GlobalScope is actually a companion object. And in the previous video, we created our first coroutine using this syntax. Now don't worry, we will shortly discuss what is the difference between the GlobalScope.launch and only the launch function. Similar to this for async as well, we have GlobalScope.async function. But for runBlocking, we don't have anything like that. We just have simple plain runBlocking function. Fine. So let us first get some clarity on what is the significance of using GlobalScope companion object with the launch function. Well, let us assume we launch an application. So this entire red box represents the lifetime of the application. Let us assume that. Now, in your application, suppose you are currently in a login screen. And from this screen, you launch a coroutine C1 using the launch function. And then you navigate to another screen, maybe a home screen or something like that. And here as well, you launch another coroutine C2 using the launch function. Now, so far, so good. But when you try to close this screen and navigate back to the previous screen, then what happens is that this home screen gets destroyed. And along with this screen, the coroutine C2 is also destroyed. Now the question arises, why the coroutine C2 was destroyed? Well, this launch function creates a coroutine in the local scope. So when the scope of home screen is destroyed, then the child coroutine such as C2 is also destroyed. In short, the lifespan of this coroutine exists within the lifespan of its local scope. Fine, so please note this. Similarly, when the scope of this login screen will get destroyed, then ultimately this coroutine C1 will also get destroyed. Like this. Perfect. Now moving on, what about if we create a coroutine using GlobalScope.launch function? Well, using this syntax, we actually create a coroutine at global level or at the application level. So, the global coroutines are top-level coroutines, and it can survive the entire lifespan of the application. So even if all the local scopes are destroyed, then also the global coroutine, no matter from which part of the application it was launched, it can survive the entire lifespan of the application. Fine. So please note this. Now the question arises, when should you launch coroutine globally and when should you launch a coroutine locally? Well, to be honest, it is a subjective question and would require a separate discussion on that. But for now, I will show you a big picture. So, you can use global scope in cases where you don't depend on the local scopes. For example, once you click on a button to download a file, then the download operation can run in the global scope and let it complete in the background, because generally the downloaded file is not needed during your ongoing activities in your application. So you just start the download operation and move on with your other work. Fine. The same is the case of playing the music. Just start playing the music and it has nothing to do with your other ongoing tasks. Great, isn't it? Now, moving forward for the launch function, you can use it where you want to compute some values within a local scope and end it there only. Or you want to log in and you need to end that login operation right there. Then you can simply use the launch function. So I hope it makes sense now when to use what. Now moving on, at the end, also note that using globalscope.launch is highly discouraged, because if you create a coroutine globally and you forget about it or lost the reference to the coroutine, then that coroutine will keep on running in the background and consume a lot of memory, right? Which is not good actually. So if you use a global coroutine, then you need to use it very carefully. In short, using launch function should be your default choice. So please note this. Nice and simple. Now, similar to the case of launch function, in case of async function as well, we can use GlobalScope companion object to launch the coroutine globally. Well, the gist of the difference between these two remains the same. But this does not mean that launch function and async function are the same. Well, they are different. And this is what we are going to discuss in this video. So let us start with the launch function. So here, this is the same program which we wrote in the previous video. Here we start our main program. Then we create a global coroutine that runs on a global thread in the background. Here are the coroutine operations. Then we wait for the coroutine to finish. And since this is a suspending function which we cannot use directly inside the main function, so that is why we used runBlocking over here. Fine, I hope you remember this. If you run the program, we get this output. I guess nothing new until now. But please note the name of the thread on which our coroutine is running. I will come back to it shortly. Now, as mentioned just now, you should not use GlobalScope companion object unless required. Right now we are performing a very simple operation within our coroutine. So we don't need to run it in the GlobalScope, right? So let's remove GlobalScope from here and run the program again to see the difference. So here we go, we have some twist. The coroutine is now running in the main thread. Interesting, isn't it? So accordingly, let us update our comment. Now the question arises, why on this holy earth our coroutine ran on the main thread? Well, this is because this launch coroutine builder is actually present within the scope of the parent runBlocking coroutine builder. And since this runBlocking runs on the main thread, so this child coroutine inherits the scope of the parent coroutine and hence runs on the main thread. Fine. Well, this is the property of the launch coroutine builder which you need to remember. So in short, if this runBlocking coroutine runs on suppose thread T1, then this launch coroutine is going to run on the thread T1. That is, it will inherit the thread and the coroutine scope of the immediate parent coroutine. Fine, so please note this. This is very important. Great. Next, within this coroutine, the first statement will of course run on the main thread. But when the suspending function delay is executed, then our coroutine suspends, right? Which means the next statement will either execute on the main thread or some other thread. Well, it depends on the situation which I explained in the previous video. So I guess you are getting a clearer picture now. Now moving ahead, let us explore more. Let us see the definition of this launch function. So if you take a look at the documentation, then you will find that this launch function is actually an extension of this CoroutineScope interface. Right? And this function returns a job object. Now, what this job object stands for? Let us explore that as well. So, from this function, we are getting a job object. Right? And using this job object, you can control this coroutine. Let me show you how. Now, as mentioned earlier, the usage of delay over here is not the right way to wait for the coroutine to finish its work. So instead of this statement, what you can do is you can use job object and call the join function. So this join function will wait for the coroutine to finish its execution, only after which the next statement will be executed. Let us run the application and see what happens. So here we go, our program worked perfectly fine. So in this way, you no longer have to hard code the time over here. Just use the join function and you are done. Also, please note that using this job object, you can also cancel the coroutine by calling job.cancel method. Well, right now I am not going to explain you about the cancellation process of the coroutine because cancellation is a huge topic and requires a detailed explanation. So for now, this much information is enough. So let us summarize the launch coroutine builder. So when this statement is executed, then it creates a coroutine that operates on a thread. And of course, on this same thread, there could be other coroutines that can operate at the same time. And you already know this from the previous video. I am just giving you a quick recap. And when this delay function is executed, then it basically suspends the coroutine. But remember, the thread remains free for this time period. And other coroutine can still continue to operate on this thread. Only the current coroutine is blocked for this time period. And this launch function returns a job object, right? So using this job object, you can wait for the coroutine to finish or even cancel the coroutine. So in short, this launch coroutine builder creates a coroutine that runs without blocking the current thread. Always remember this, it does not block the thread on which it operates. Also, this coroutine inherits the thread and the coroutine scope from the immediate parent coroutine, which we saw in our demo. Next, this function returns a job object. And using this job object, you can cancel the coroutine or wait for the coroutine to finish. Basically, this job object allows you to control the coroutine. Fine, nice and simple. Now before I end this topic of launch Coroutine Builder, here within the parenthesis I have written fire and forget. Well, this Coroutine Builder is also known as fire and forget Coroutine Builder. So let me give you a task over here. Just go to Google and search for why launch Coroutine Builder is known as fire and forget Coroutine Builder. Now moving on, it is now time to explore Async Coroutine Builder. Well, this is very similar to the launch Coroutine Builder, but with a little difference. So let us explore that difference. So here in place of launch, just use async. And that is it, you are done. You have just created a coroutine using async function. And similar to the launch function, this async will inherit the CoroutineScope from the immediate parent coroutine, which is runBlocking in our case. So let us run our program. So here we go, the output remains the same. But there is a difference between the launch function and the async function. Well, this function does not actually return the job object. It basically returns the deferred object, which is actually the subclass of the job object. And this deferred is of the generic type. So right now from this lambda expression, we are not returning anything. So we can put unit here. Right? And in case if you return a string from here, such as my name, then in that case instead of unit, just use string. And if you want to return a integer value from this lambda expression, then use int here. Great. And instead of this job, now use this job deferred object. Great, isn't it? Now, if you don't want to use this 15 in your code, then just calling join function will wait for this coroutine to finish its work. But if you want to use this returned 15 in your code, then instead of this join function, you can use job deferred object dot await function, which is very similar to the concept of future and promise in case of JavaScript. And on the left, you can retrieve that value of the type int by using this statement. And then you can use this num variable in your code. Fine. Now just remember, just like this delay function, the await function and this join function are also the suspending function, which means you can use them within a CoroutineScope, which in our case is being provided by this runBlocking Coroutine Builder. So please note this. Now moving on, if you use GlobalScope companion object over here like this, then in that case you are going to launch a global coroutine that will run on the GlobalScope at the application level. So if you run the program now, then you will find your coroutine is now working globally at the application level thread. Fine, but in our case we don't require an application level coroutine. So let us remove it from here. Now at the end, let's see the signature of this deferred class. So if you go to the documentation, you will find that it is actually an interface and it is basically a subclass of the job interface. So that is why in our program, we were able to call the join function, or even you can call the cancel function on this deferred object, because this deferred is actually a subclass of the job interface. So now let us summarize the async function or the coroutine builder. Well, just like launch function, the basic properties of the async function and the way it operates remains the same. For example, how calling the delay function just suspends the coroutine, it remains the same. But using async function, you can return some data, and you can retrieve that data using the await function. And of course, you can call the join function or the cancel function as per your need. So in short, The await function, just like the launch function, creates a coroutine without blocking the current thread, and it inherits the thread and the scope from its immediate parent coroutine. Next, this function returns the deferred object, which can carry your desired result. And finally, using that deferred object, you can cancel the coroutine, or wait for coroutine to finish, or even retrieve the returned result. How cool is that? Moving ahead, let us see runBlocking Coroutine Builder. And what is it used for? Well, practically, we don't use runBlocking Coroutine in the way we have used it in our program. We have used it over here so that we can run suspending functions like await or join over here. You can think of it like I am using runBlocking just to explain you how coroutine works. But this is not the right purpose of using runBlocking in our program. So the question arises, what is the practical use of runBlocking function? Well, this runBlocking is generally used to write test cases to test the suspending functions. For example, suppose if we have a suspending function such as my own suspending function, which performs some operation. Let us represent the dummy operation by using the delay function, like this. So to test this function, you would need to write test cases. Let us do that. So here in Kotlin, let us right click, go to new, and create a new Kotlin file. Let's call it simple test and create the class. Now, to write JUnit test, you need to integrate the JUnit library in your project. So in your Gradle file, in your dependencies, just add this statement. And from this icon over here, just load the changes. Once you are done, let's write our first test case. So to write the test case, all you have to do is use @test annotation that belongs to org.junit.test package, and then define your function such as my first test. Now, how do you test something? Well, we test something by asserting values. For example, we can use assert that belongs to JUnit dot, let's use the function of assert equals, and pass two parameters. The first is the expected value and the second is the value which you want to test, such as 5 plus 5. So this function is going to check if this 10 is actually equal to this 5 plus 5 or not. And before we run our test, you need to do some changes in your project configuration, such as go here and go to edit configuration, and from here click on plus, that is add new configuration, which I have already done in my project. Right, just from the drop down select this JUnit, you will get this icon over here, and from this test kind select all in packages, then select in whole project, click on apply and then OK. Once you create the configuration, click on this run button over here. So here we go, our test passed. Fine. Now suppose if we want to test this function of my own suspending function, so in that case let us call this function from here. But if you try calling my own suspending function from here, then the compiler won't allow you to do that. It will say you cannot call a suspending function from within a normal function. And as per the rule which we saw in the previous video, we can only call suspending function either from within a coroutine or from within another suspending function. Right? I hope you remember that. So how to make our test case work? Well, in that case, we can make use of the runBlocking function. So here I will use runBlocking like this, just like we were using it in case of the main function. So this runBlocking is a coroutine builder that is going to launch a coroutine. and that coroutine is going to block the current thread in which it is operating and therefore will help you to execute this suspending function. Let us run our test once again. So here we go, our test again passed, which means the code within this whole function passed. Fine. So this is the actual purpose of using runBlocking Coroutine Builder. And of course, later on in this series, I will definitely show you what are the other used case of this runBlocking coroutine. For now, this much information is enough. Now in the end, please note that this launch and async coroutine builders never block the thread in which it operates. But this runBlocking coroutine builder always block the thread in which it operates. And this non-blocking and the blocking nature of these coroutines are very important for you to remember. Nice and simple. So finally, let us summarize our video. Well, in this video we explored what are coroutine builders such as launch, async and runBlocking. Remember, launch and async are non-blocking in nature. But runBlocking is a blocking coroutine which blocks the thread in which it runs. We explored what are the differences between launch and async coroutine builders. Then we explored what is GlobalScope companion object and why you should avoid using it. We also saw the usage of deferred object, and it is actually a subclass of the job interface. Also, we explored how to use await, join, and cancel functions. Hey, but wait, we did not explore anything much about this cancel function, because cancelling a coroutine is a huge topic of discussion.
So for that, you must watch next chapter of this course. So congratulations on completing the second chapter. So without wasting any time, let's jump on to our next chapter. So again, this is Shreng Siddharth and I welcome you all to the next chapter of this course. In this chapter, you will learn in detail about
Coroutines in terms of cancellation, timeouts, and how to handle cancellation exception in a coroutine. So let's get started. Now, the first question that comes to my mind is, why would you cancel a coroutine? Why can't we just let it finish its work for which it was meant to be? Well, there are several reasons for which you would need to cancel the coroutine. There might be a case where you no longer need the result from the coroutine. In that case, you can cancel the coroutine. If the coroutine is taking too long to perform a task, then you can cancel that coroutine and find another way to execute the same task. In short, the reason of cancellation could be anything. So let's explore how to cancel a coroutine. Now, to cancel a coroutine, the coroutine has to be cooperative. So what does this mean? Well, I am going to keep a suspense on what does cooperative mean exactly for next few minutes. So right now, don't worry about this term cooperative. So right now, just remember, to cancel a coroutine, it has to be cooperative. Now, let us take a look at a sample code. Here we have a coroutine, and the code within your coroutine has to be cooperative in order to get cancelled. Please note this. Now, to cancel the coroutine, we need to call cancel function on the job object. So if your coroutine is cooperative, then it will get cancelled. But if your coroutine is not cooperative, then it will not get cancelled and it will continue to operate in the usual manner. And when your coroutine fails to cancel, then this join function will wait for the coroutine to finish. In short, this join function will be effective only when this cancel function fails to cancel the coroutine. So again, please note this. This is very important. So basically this cancel function and join function are used in conjunction. They are used so often that we have a separate function that combines the property of these two functions. So in place of them, we can use cancel and join function. So when this function is called, then if the coroutine is cooperative, it will get cancelled. Else, if the coroutine is not cooperative, then it will wait for the coroutine to finish. So I hope it makes sense now. Now, it is time to unveil the biggest mystery of this video. What exactly we mean by the term cooperative? What makes a coroutine cooperative? Well, there are basically two ways to make a coroutine cooperative. The first way is to periodically invoke a suspending function that checks for cancellation. And only those suspending functions which belong to KotlinX.Coroutines package will make your coroutine cooperative and therefore cancelable. For example, the functions like delay, yield, etc. are the suspending functions which belong to that package. And if you use these functions in your coroutine, then your coroutine will become cooperative and therefore it can be cancelled by calling the cancel function. Feeling confused? So let us see practically how to make our coroutine cooperative by using this step so that you can correlate things all together. So here we have a very simple program using coroutine. Here we are applying runBlocking CoroutineScope. Then our program starts. We create a non-blocking coroutine by using the launch function. Even you can use the async function over here as per your wish, but I am using the launch function. And this coroutine contains a for loop which prints values from 0 to 500. Then we wait for coroutine to finish. And finally our program ends. So right now our program is very simple. If you run the program now, so it is going to print the values from 0 to 500. I guess I am using 1000 over here, so that's why it is going to print the values from 0 to 1000. So let's make it 500 and run the program again. Okay, so here we go. It prints the values from 0 to 500 like this. And then our program ends. Great. Now let us put some delay while printing values. Let us use Thread.sleep function and sleep for 50 milliseconds after each iteration. Well, I am using Thread.sleep instead of delay function. It is intentionally just to show you something. Let us run our program again. So now our program print values at interval of 50 milliseconds. So altogether it takes 10 seconds to complete the coroutine, right? But I think as a user, 10 seconds is way too much. So in that case, I would like to cancel the coroutine. So let us terminate my program because I can't wait for 10 long seconds. And here, just before the join function, I will use job.cancel function to cancel my coroutine. But since our coroutine is going to get launched in the background thread, hence it could immediately get cancelled. So let us add a delay function of 200 milliseconds. So this delay function is going to print a few values before the coroutine gets cancelled. Let us run our program. So here our program is running, but there is no signs of cancellation. Our program is running throughout for 10 complete seconds, which means our coroutine did not get cancelled. Right? Now the question arises, why? Well, the reason is at this point of time in our program, our coroutine is not cooperative. Because as per the statements written over here, in our coroutine we are not using any function that belongs to this package. So we have to use either of these functions that belongs to KotlinX.Coroutines package, which will make our coroutine cancelable. So right now in our coroutine, we are just using a print function and Thread.sleep function. Now these two functions do not belong to this KotlinX.coroutines package. Therefore, our coroutine is not cancelable. So even after you call job.cancel, our coroutine continues to work until it finishes its task, right? So let us replace Thread.sleep by delay function. And this delay function belongs to this package. And if you look at the documentation of this delay function, then you will find that it says this suspending function is cancelable, and hence it makes our coroutine cancelable. So with each iteration, this function is going to check if our coroutine has got cancelled or not. If it is cancelled, then at a particular iteration, it will cancel the entire coroutine. Fine. So let us run the program and see what happens. So here we go, we printed a few values and then our program ended. Nice and simple. So in this way you can make your coroutine cooperative and therefore cancelable. Now instead of using job.cancel and job.join in two statements, you can use job.cancelAndJoin function, like we saw in our slide. Run the program again, and the output remains the same. Great, isn't it? Now, apart from delay function, we also have other functions like yield function. So in case you don't want your coroutine to delay, then yield function is the best choice for that. Let me show you how to use this function. So instead of delay, let us use yield function. Well, this yield function is cancelable in nature. If you take a look at its documentation, then it says this function is cancelable. Fine. And it also does not delay your coroutine. So either you can use yield function, which is faster than your delay function because it does not delay your coroutine, or you can even use delay function or any other suspending function that belongs to this package as per your requirement. So please note this. Now since we are not using the delay function, so our coroutine won't get delayed, right? And this yield is going to make our coroutine execute very fast. So using delay of 200 is going to print all the numbers from 0 to 500, right? So let us reduce this time to, let's say, 10 milliseconds. Let us run the program. Fantastic, we are printing a few values and our program ends. You can even increase the time to, let's say, 20 or 30 milliseconds in order to print more values. It totally depends on your requirement. So yes, this was all about the first way to make your coroutine cooperative and therefore cancelable. Now moving on, let us check the second way to make our coroutine cooperative. Well, there is a Boolean property of isActive, which is an extension on the CoroutineScope class. And this flag can be used to check for cancellation status of the coroutine. So when the coroutine is active, then this flag is true. But when the coroutine is cancelled, then this flag becomes false. So using the false value of the flag, we can terminate the coroutine internally. Now, just for an extra information, in case of threads, we do not have any such flags. We are glad that in case of coroutine, we have got a provision for terminating coroutine based on a Boolean value. So this is another advantage of using coroutine in place of threads. Again, please note this. So firstly, let us remove this yield function. The next step would be to check the Boolean flag is active. So right within the loop, just before the print statement, we can use if is active, then actually break. Well, I mean to say if the coroutine is not active, then just break out of this for loop and therefore our coroutine will finish. That is, it will terminate automatically. And also within the launch function as a parameter, you need to pass dispatchers.default. Now, this topic of dispatchers we have not explored yet, but we will explore it shortly, don't worry. So, let us run the program right now. Well, here we are getting all the values right from 0 to 500. Well, it is not because our coroutine is not cooperative. This is because our coroutine is getting executed very quickly. That is, even before we try to cancel the coroutine, our coroutine is getting executed. So let us add some delay over here. For that, right now I will use Thread.sleep function. And let's put a delay of 1 millisecond. Now I can use delay over here, but delay function will automatically make our coroutine cooperative. But we want to test that if this isActive flag is working or not. That's why I am using Thread.sleep function. So please don't use this function in your real projects, right? Let us run the program again. So here we go, our program started and we got values right from 0 till, I guess, 73, right? Which means our coroutine executed for a few milliseconds, and then as soon as this function was executed, then this flag isActive became false, which eventually executed this break statement which broke out of the for loop and therefore finished the coroutine, which you can see in the output over here. So this is how we use isActive boolean flag to make our coroutine cooperative. Now, instead of this break statement, you can also use, let's say, return statement, return at the rate launch. So what this return at the rate launch will do, it will return at the coroutine level, that is at this level. So as soon as this statement is executed, no more code within the coroutine will be executed further, which means our coroutine operation is now over and we are returning at this level, therefore terminating the coroutine. Fine. So let us run the program and see what happens. So here we go, we got almost the same output, just that we are printing less number than before. But that's okay, our program executed faster compared to the previous launch. So in this way, by using the isActive boolean flag and by checking it at regular intervals in each iteration, we can make our coroutine cooperative and hence cancelable. Nice and simple. Now that we know two different ways to make our coroutine cooperative, let us now move ahead with the next section of this video and explore how to handle exceptions while cancelling the coroutine. Well, this is yet another important topic related to the coroutine cancellation, so let's explore it as well. Now, when you cancel a coroutine by using suspending functions within it, then cancellation exception is thrown by that suspending function, which you can handle by using try and catch block. In short, all the cancelable suspending functions such as yield, delay, throws cancellation exception when the coroutine is cancelled. So please note this. So here, let me modify the program and use the same program which we saw using the yield function or the delay function earlier. So when you cancel your coroutine, then this delay function, which is actually the suspending function, throws a cancellation exception. So we can wrap our for loop within try catch block. And within the catch block, you can write your code. Great. And just like any other try catch, you can also add a finally block and print something like this. If you run the program now, then our program started and we printed some values and When we cancel our coroutine, then an exception is thrown, which is caught within this catch block. So we print this statement and then closed resources in the finally block. Right? Perfect. Now moving on, instead of this delay function, you can also use the yield function. Or if in case in place of these two functions, if you have any other suspending functions that belongs to this Kotlin x.coroutine package, then that suspending function will also throw cancellation exception. So please note this. Any suspending function that belongs to this package is cancelable and is going to throw this cancellation exception. Fine. Next, you cannot execute a suspending function from the finally block because the coroutine running that code was already cancelled. But in the extreme case, if you really want to execute a suspending function from the finally block, then you can wrap that code within withContext non-cancelable function. So let's see the code in action. So within our finally block, let us put a delay function over here, which is actually a suspending function. And let us run the program. So here you will find that we have caught our exception. But then the finally block was not executed because at this statement, at the statement of delay, another exception was thrown, which resulted in the non-execution of this print statement. So that's why we are not getting the output from the finally block in the output console. Well, we generally don't use suspending functions within the finally block. But in the rare case, if you need to use such functions, then you can wrap your code within withContext function. Like this. And as a parameter, you need to pass non-cancelable companion object. Now, this withContext function is actually a coroutine builder. So this function is going to start a new coroutine in another context, which will execute this suspending function, right? So let us run the program and see what happens. So here we go, we got close resources in finally in the output console. Great, isn't it? Now, moving on, you can also print your own cancellation message by using job.cancel function. And as a parameter, you can pass CancellationException instance and pass your message within the constructor which you want to print. So here within our program, let us split this function into .cancel and then job.join. Once you do it within this cancel function, you can pass CancellationException instance and within the constructor just type your message which you want to print. Like this. And then within the catch block over here, you can print that message by using ex, which is actually the variable we have defined here, dot the message property. Fine. Let us run the program. So here we go, exception caught safely and my own crash message. We are able to print it in the output. How cool is that? So in this way, we actually handle cancellation exception in our coroutine. Perfect. Now that we know how to handle exceptions, let us move on to the next section of this video, that is timeouts. Well, suppose you launch a coroutine that is taking more time than expected to finish its work. Then in that case, you can cancel your coroutine. And for the time-bounded task, Kotlin provides us with special functions, such as the function of withTimeout, and also we have withTimeoutOrNull. Well, these two functions are basically the coroutine builders. That is, just like launch and async functions, they also create coroutines. So let us see how to use them in our program. So here in our program, let us clean up our code, because we are going to write a very simple and clean code. So right here, let us use withTimeout function. And within the lambda expression, let us use a for loop just to perform some task. And as a parameter within the timeout function, you need to pass the time you expect this coroutine to execute and finish its work. Suppose I expect my coroutine to finish my work in 2000 milliseconds, that is 2 seconds. And in case if my coroutine fails to finish the work within this time period, then let's see what happens. For that, let us run the program. So here we go after 2 seconds since our coroutine failed to finish. Then in that case, timeout cancellation exception was thrown because the timeout function waited for 2000 milliseconds, and thereafter since our coroutine did not finish, it threw timeout cancellation exception. So just like cancellation exception, you can also handle this exception by using try catch block. You can also add finally block as per your wish. Now, this timeout cancellation exception is basically a subclass of cancellation exception, which we saw just now in this video. Right? So please note this. This class is basically the subclass of the cancellation exception. So moving on, let us explore withTimeoutOrNull function. So if we use withTimeout or null over here and pass 2000 millisecond like this, then the functionality of this function remains the same. This function is going to create a new coroutine. That is, this function is also a coroutine builder. But the difference between withTimeout and withTimeoutOrNull is that this function is not going to throw any exception. So we can remove this try catch and finally block. So now, what is the purpose of using this function? Well, this function basically returns some value from the coroutine in the form of lambda result. That is, if you put some value at the end like this, then this value is going to get returned from this coroutine, right? And you can get that value right here, like this. And in case if you put some value such as 15 over here, which is an integer value, then in that case you need to change your data type over here. I think you are aware of this. So let us use the string over here, and then you can use this value result in your program like this. Now also please note that in case if there is a timeout, that is our coroutine is unable to finish the task within 2 seconds, then in that case this result will get the value of null. That is, instead of this string value, we will get null over here. So let us run the program and see what happens. So there we go, we got null finally, because there was a timeout. And also remember to make the data type of this variable as nullable type, so that this result can store the nullable object. Perfect. So yes, this was all about timeouts in case of coroutine. So yes, finally we have reached the end of this video. This was a pretty long video, so let us get a big picture of what we learned so far in this video. Initially we learned what makes a coroutine cooperative, that is, cancelable. Then we explored two ways to make coroutine cancelable. First, by using the suspending function within the coroutine, such as delay or yield functions. Then second, by using isActive boolean flag. Then moving on, we explored how to handle cancellation exception while cancelling a coroutine by using try catch and finally blocks. And along with this, we saw how to use withContext function to execute a suspending function within the finally block. Then we explored the topic of timeouts. And for that we saw withTimeout function as well as withTimeoutOrNull function. And in case of withTimeout function, we also saw how to handle timeout cancellation exception, which is basically a subclass of the cancellation exception.
So yes, that is it for this chapter. I hope this chapter has expanded your horizon to understand coroutine better. So let's move on to the next chapter. So again, this is Shreyang Siddharth and welcome to the next chapter of this course. That is chapter 4. In this chapter, we will see
Various approaches to compose and execute suspending functions, such as we will explore the sequential, concurrent, and lazy execution of the suspending functions within a coroutine. And trust me, having thorough knowledge of this will really help you to use coroutines in your application. Now before you start with this video, there are a few things that you should already know. The first is, you should know the basics of coroutine, such as what is a coroutine and how to create a coroutine. Along with this, you should also know what are suspending functions. Next is, you should be familiar with what are coroutine builders, such as launch, async, and runBlocking functions. So let us now see what we are going to cover in this video. We will first see how functions execution within a coroutine are sequential by default. Then we will find a workaround to make them concurrent. That is, execute those functions in parallel instead of sequential. Then finally we will explore how to execute a block of code lazily using coroutine. And if this term lazy is new to you, then don't worry, you will understand what it means when we will see its demo. Well, it is something from the Kotlin programming language. So without wasting any more time, let's begin. So here we have a very simple program. Let's go through each line of code one by one. So this is a suspending function which returns a message in the form of string. Then we have another suspending function which returns another message, again in the form of string. Now please note that in both functions we are using delay of 1 second. We are basically pretending to do some work for 1 second. Now here we have our main function. We are using runBlocking Coroutine Builder over here, which means our entire main function now executes within this runBlocking coroutine. Fine. Here our main program starts and then it ends here, and within this we will write our code. So I guess no doubt till now. Now let us call these two functions from within our main function. So I will replace this comment by the function call. So here I will call getMessage1 function and store the returned value within a variable, like this. Similarly, I will call getMessage2 function and store the returned value within another variable. Great. And then I will print the entire message by joining them using a print statement. Now also note that these two functions executions are getting executed within a coroutine of runBlocking. Fine. Let us now run the program and see what we get. So here we go, the output is as expected. But what is worth here to consider is how these two functions are being executed, how they are being called within our coroutine. Are they getting executed in sequence or are they getting executed concurrently? Well, we can easily know that by checking how much time is elapsed while executing these two functions. So for that I will use measureTimeMillis function, which belongs to this package. Now this function is going to measure the time taken by this code over here to execute, and we will get the time taken to execute in milliseconds in this time variable. So once we get the time, we can actually print it. And let us put these two code within our measure time millis function like this. And I think we also need to put this code right over here. Great. So let us now run the program and see how much time this code is going to take to execute. So here we go. It took almost 2 seconds to execute the two functions, getMessage1 and getMessage2, which means 1 second was consumed over here and another second was consumed over here. That is 1 second for each function, which we can see here. So in short, this means that within our main function, these two lines of code took around 2 seconds for execution, which means they were executed one after another in sequence. That is, they were executed sequentially. So here you can note one thing. Within a coroutine, which in our case is the runBlocking coroutine, by default the methods are executed in sequence. Fine, that is from top to bottom. Not only these two functions, even this print function, this measure time millis function, then these two functions, then again these two functions are all getting executed in sequence by default. That is, the execution flow is from top to bottom. Fine, so please note this. So if somebody asks you how the methods are executed within a coroutine, then without any hesitation, just say they execute by default sequentially. Nice and simple. So now that we have seen the sequential execution, let us move ahead and see how we can make some arrangements to execute those functions concurrently. Now for beginners who don't know what concurrent means, well, in simple words you can assume concurrent means parallel. So here, as mentioned, these two statements or functions are getting executed sequentially. Now, if we wrap these two functions within async or launch coroutine builders, that is, we create another child coroutines within this runBlocking coroutine, then let's see what happens. What I'm trying to say is, if we use or create a child coroutine using async coroutine builder over here, and also launch another child coroutine using async function over here like this, then we all know that this async function returns a value in the form of deferred object. That is, whatever is the last statement within this function of async will be returned in the form of deferred generic type object. So on the left, just to avoid any confusion, let us use deferred of the type of string. And repeat the same over here, just to avoid confusion. And from this variable, we can get the exact string value using the await function. So over here, we can use await and also dot await over here. So let us now run the program and let's see what happens. So here we go, the output remains the same. The only difference you will notice is in the time taken to execute these two functions. Right now it takes only 1 second to execute these functions. So let me explain you what exactly is happening. Well, this async function is actually a coroutine builder. It creates another child coroutine within the scope of this parent runBlocking coroutine, right? So this child coroutine executes this function in a separate background coroutine. Similarly, when this child coroutine async is getting executed, then again it launches another background coroutine that runs in parallel to the previous background coroutine which is executing this function. So in short, these two child coroutines are getting executed in parallel, that is, in concurrent manner. And that is why instead of 2 seconds, these two statements were altogether executed within just 1 second. So I hope it is now clear how you can achieve concurrency using async function. Now how can we achieve concurrency using launch Coroutine Builder? Well, we can use launch over here and also over here. But the problem with launch is that you cannot return a value from the launch Coroutine Builder. But in our program, we are expecting some value which we can use in our program, right? So that is why instead of launch, I used async over here. But remember, using the launch Coroutine Builder, you can also achieve concurrency. Nice and simple. And also within this async function, if you want, you can write your own code like this. But remember, the return type of these two variables truly depends on what you are returning from the last statement of your Coroutine Builder. So yes, that's all for this topic. So let us move to our next topic of discussion, that is lazily execute a coroutine. Let's see how to do it. Now before we start, let us do some changes to our program. Basically, let us simplify our code a little bit. Also for this demo, we won't care about the time consumed by our code. So let's remove everything related to measure time. And in our suspending functions, let us add a print statement. So using these two print statements, we can know these functions are getting executed. Now, coming back to our main function. So here, what we are receiving as a result in these two variables, we are using them over here in our print statement, right? But if we comment this print statement, then basically executing these two child coroutines are of no use, because we are not using the returned result in our program, right? They remain unused. But if you run the program, then you will see that the suspending functions are getting executed, which is evident from these two print statements. So basically, these two suspending functions which are getting executed are wasting system resources without giving any fruitful result in our application. So to avoid this, in Kotlin, we have a workaround for that. We can optimize our code. We can make our coroutine execute only if we use the result in our program. So to do that, we can just pass as a parameter, just use start equal to coroutine start dot lazy, like this. And the same can be applied to the second child coroutine. Great. So if you run the program now, then you will find that those two suspending functions were not executed because we are not using these two results in our code. That's why the system did not find it useful to execute these two coroutines. How cool is that? So in short, only if you use these two values in your program, these coroutines will get executed. So if you uncomment this statement and run the program, then in that case, of course, those two suspending functions will get executed, which is evident from these two print statements, right? And also we are printing the result, hello world. So now let me explain to you how the coroutine execution takes place. So when this statement is executed, then this coroutine does not get executed. And also when this statement is executed, then again this async coroutine does not get executed. But when it comes to this print statement, then first message1.await is executed. So when this statement gets executed, then at this point of time, it starts your coroutine. So this getMessage1 function gets called or executed. And once in place of this code, we get hello. Then right after this statement is executed, message2.await. Then again our program feels the need to get this data. So for that it starts to execute our second child coroutine. So one by one we get these two values, and then we get the entire output in this print statement. Nice and simple. So I hope you get an idea of what is meant by lazily starting a coroutine in Kotlin. So yes, that's all for this topic. So in this way, finally we have reached the end of this video. So in this video, we basically learned about how to compose suspending functions and execute them. Firstly, we saw how code within a coroutine are sequential by default. And to achieve concurrency within a coroutine, you can either use async or launch functions as a child coroutine builders. Then finally, we saw how to lazily start a coroutine using async function and therefore optimize your code.
So yes, that is it for this chapter. In the next chapter, we will explore CoroutineScope, CoroutineContext, and dispatchers. And trust me, these are the very sophisticated topics of coroutines that many developers get confused upon. So let's jump on to our last and final chapter, that is chapter 5. Hi, again this is Shreyank Siddharth and let's start this chapter 5 with great energy and enthusiasm. I am totally excited for this last chapter. Are you?
Now the topic of coroutine context and dispatchers is something which is like a nightmare for every developer. So I will try to answer all your small and big questions. So stay tuned with me until the end of this video. So yes, let's start with Kotlin Coroutine Scope. What it means actually. Well, we all know that launch function is a coroutine builder. It creates a coroutine. Now, when it creates a coroutine, then by default it gets attached to a special instance of CoroutineScope. So, within this lambda expression, if you use this keyword, then basically you will get access to the CoroutineScope instance. So in short, every coroutine has its own CoroutineScope instance attached to it. And this is something you need to remember. Similarly, the coroutine builders like Async or runBlocking coroutine builders also has a CoroutineScope object attached to it. Fine, I hope you get it. So here we have runBlocking coroutine as a parent coroutine builder for this main function, right? So when it creates a coroutine, then attached to it we have the instance of CoroutineScope, which you can find it here as a hint by the IntelliJ IDE. So within this lambda, if you use this keyword, then you will be able to access the CoroutineScope object. So if you print this keyword using a print statement, then let's see what happens. Let us run the program. So here this entire output represents a CoroutineScope object. Also the signature of CoroutineScope shows what kind of coroutine was created. Since we were using a runBlocking coroutine, so that's why it is showing a blocking coroutine that blocks the main thread, right? And this active shows that when this statement was executed within the coroutine, then the coroutine was in active state. And right after this we have @some value, right? So this value is basically the hex value. And this hex value represents the hash code of the object. So basically this hash code represents the uniqueness of the object. Fine. Now similarly, if you use a coroutine such as launch coroutine or async coroutine builders and print the CoroutineScope objects using the print statement like this and run the program, then you will find that the launch coroutine builder creates a standalone coroutine and the async coroutine builder creates a deferred coroutine which returns a deferred job object. So basically the CoroutineScope represents what kind of coroutine you have created. Quite simple, isn't it? Now, what about the CoroutineScope of the child coroutine? So here within this launch coroutine, if you add a child coroutine like this and call it child launch, run the program and let's see what happens. then you will find that this is the parent scope of launch coroutine, right? And this is the coroutine scope of the child coroutine. So here you will notice this coroutine scope and this coroutine scope instance are different objects, which you can make out using the hash code value, right? They both are different. So this shows that every coroutine, irrespective of being a parent or a child, has its own coroutine scope. Nice and simple. Now moving on, we have coroutine context. Well, this topic is going to be a bit tricky, but don't worry, we will tackle it in our own way. Well, similar to CoroutineScope, every coroutine has its own coroutine context, but with a twist. As mentioned, the coroutine scope is unique for each coroutine, right? But coroutine context can be inherited from parent to child, meaning the child coroutine can inherit properties from the parent coroutine. Now this coroutine context has basically two major components, such as a dispatcher and a job object. Now this dispatcher is very important. It is the dispatcher which decides on which thread the coroutine will execute. So please note this, it is the dispatcher which decides the thread of the coroutine. This is very important. And you are already familiar with what this job object means and how using the job object you can control your coroutine. I hope you remember this from the previous videos. And apart from these two, you can also assign a name to the coroutine. Fine, which we will explore later. So let's understand things better in a demo. Now here we already have some code which you can get from the link in the description. So for the next few minutes I would suggest you to just focus on what I am saying. Don't worry about the code. You can anyways get the code from the GitHub link in the description. Well, just now we talked about the coroutine scope, right? How with every coroutine there exists a coroutine scope. So similar to coroutine scope, with every coroutine there exists a coroutine context. And within this coroutine of runBlocking, if you want to access the coroutine scope, then you can use this keyword, right? Which we saw just now in our previous demo. Similarly, if you want to access the coroutine context of this coroutine of runBlocking, then in that case there exists a property of CoroutineContext. Fine, so using this property you can always access the coroutine context of the current coroutine. Great, so let's document it. Now let us see how the coroutine context play a role in determining the thread for each coroutine. Let us start with the coroutine without parameter. Well, this is also known as confined coroutine, which I will talk about shortly. So when you create a coroutine without any parameter, like this, then it is going to inherit the coroutine context from the immediate parent. That is, this coroutine is going to inherit the coroutine context of the parent runBlocking coroutine, which means this child coroutine of launch is going to execute on the main thread, which is the thread inherited from this runBlocking coroutine, right? So here, let us use thread main as a comment, so as to avoid any confusion. So if you type a print statement over here, then this statement should execute on the main thread, right? Let us run the program and let's see the proof. So here we go, the coroutine C1 was executed in the main thread. So here is the proof, right? So in short, just remember, when you create a coroutine without passing any parameter over here, then it will inherit the coroutine context, that is, it will inherit the dispatcher from the immediate parent coroutine. Great, isn't it? Now next, we have coroutine with parameter, and this time we are going to pass such as dispatchers.default. So if you use dispatchers.default like this, then this will create a coroutine whose properties will be exactly same as the coroutine created by GlobalScope.launch function. That is, this will create a coroutine at the application level, and hence it will execute on a separate background thread. And I hope you remember the properties of GlobalScope.launch function, which we explored in the very beginning of this Kotlin Coroutine series. So again, let us print and check the name of the thread. Name it C2, run the program. So here we go, the C2 was executed on a separate background thread. Fine, so here is the proof. So let us assume this thread name is T1 for the simplicity. Now here, let us add two more lines of code, such as a delay function of 1000, and then let us print the thread name again, right? Now, in case of GlobalScope.launch coroutine, if you remember in the very first video of this series, we explored that suppose this statement gets executed in thread T1. And after this, suppose we execute a suspending function such as a delay function. Then in that case, the thread T1 gets released. And after delay function gets executed, when the next statement is executed, then it will either execute on thread T1 or even it can execute on some other thread, right? So here we can mention thread T1 or some other thread, depending on the thread availability. And here I think let's use C2 after delay, so as to avoid any confusion. Run the program. So here we go, C2 was executed in default dispatcher worker1, and after delay it is a coincidence that it is getting executed in the same thread, right? So just make a note, this thread can change after the suspending function gets executed, just like in case of GlobalScope.launch function. So in short, this dispatchers.default is exactly same as that of the functionality of GlobalScope.launch function, right? So please don't get confused here. Now moving on, we have dispatchers.unconfined parameter. So let's create a coroutine and add a print statement. Let's name it C3. Great. Now, when you use the dispatchers.unconfined dispatcher, then in that case, this coroutine is going to inherit the coroutine context from the immediate parent of runBlocking, right? So that's why this statement is going to execute on the main thread. So this is the property which you need to remember in case of this dispatcher. But right after the delay function, which is a suspending function, and suppose we add a print statement over here, such as C3 after delay, then this statement is going to execute on some other thread that is not the main thread. So here instead of T1, we can use some other thread, which will be assigned from the shared pool of thread, right? So let us run the program and let's see what happens. So here we go, this is the C3 initially got executed in the main thread, and right after delay function, it was executed in some other background thread, right, whose name is this. Now, in the end, in the first case, we actually did not notice what will happen if you add a delay function over here along with a print statement. Well, let me tell you what will happen. Well, in case of a coroutine without any parameter, the execution of the suspending function does not affect the thread of the subsequent code. That is, this statement will continue to execute in the same main thread, which was present in this first statement, right? So please note this. Now I am sure at this point of time you might have got jumbled. So let us quickly summarize what we have explored so far. So in the first case, let us expand our comment. So in the first case where we are creating a coroutine without any parameter, this will inherit the coroutine context from the immediate parent, right? Hence, the dispatcher provides the same thread as that of the parent. Fine. And even after the execution of the suspending function, the coroutine continues to execute in the same thread. So in short, the coroutine remain confined to the same thread. And as we all know that the thread which is being assigned to a coroutine is decided by a dispatcher. So that's why the dispatcher of such coroutine is known as confined dispatcher. Just because we are confined to just one thread. Fine. So next, we have a coroutine with a parameter of dispatchers.default. Well, such coroutine is exactly same as GlobalScope.launch builder. So they get their own coroutine context at the application level. So the dispatcher here provides a separate background thread. Let us assume it is T1. But after the execution of the suspending function, it might change its thread. So please note this. It will then get executed either on thread T1 or in some other thread. Fine. Next, moving on to our third case, which is dispatchers.unconfined. Well, this dispatcher is also known as unconfined dispatcher. Why? Well, in this case, the context is inherited from the immediate parent. But after the execution of the suspending function, the coroutine executes in some other thread, right? Which you can see using this print statement. So in short, the coroutine is not confined to just one thread. That is, it can change its thread in future. So such a dispatcher which might change the thread of the coroutine in future like this, so it is known as unconfined dispatcher. So again, please note this. Earlier we explored what is a confined dispatcher, and now we saw what is unconfined dispatcher, where our coroutine is not confined to just one thread. It can change its thread in future. Great, isn't it? Now in the end, let us see one more way to create the coroutine context. So here I will just copy the code from here and paste it over here, and then update the code. Let's make it C4 and here as well C4. So in this case, as a parameter, we can just pass the coroutine context property. Now this coroutine context is basically the property of this runBlocking coroutine, right? So this property actually is a part of this runBlocking coroutine. That is the immediate parent if you pass it as a parameter over here. So what this actually means? Well, when you pass the coroutine context as a parameter to the child coroutine of launch, then it will basically pass the context of parent to the child. That is, the context of this runBlocking will be inherited by this launch coroutine. So since the runBlocking was getting executed in the main thread, so that's why it will get executed in the main thread. And also note that it is like a confined dispatcher, right? So that's why right after the delay function is executed, the next statement is also executed in the main thread. Fine, so let us run the program and let's see what we get. So here we go, the C4, here it is getting executed in the main thread, and after delay as well, you can notice it is getting executed in the main thread, right? Great, isn't it? Now, let me show you one more way of proving my point. Let us cut the whole part from here and paste it within our third coroutine, that is C3. So in this case, this coroutine context will be the context of this parent, immediate parent launch coroutine, that is, which is this launch coroutine C3, right? So just before this statement, we have this statement which was getting executed in some other thread. So this some other thread, suppose it is thread T1, will be inherited by this launch coroutine, right? So instead of main thread, this statement will get executed in the thread of T1. And since it behaves like a confined coroutine, so that's why this statement will again get executed in the same thread of T1. Let us run the program and let's see what happens. So let's see C3 after delay. It was executed on this thread. Please remember this, right? So C4 was again executed on the same thread, like we have assumed here, right? This is T1, so this is again T1. And in similar way, C4 after delay was again executed on the same thread as this one, which we have assumed here as T1. Fine. So this is how we create coroutine context in several different ways. Fine. Now, coming back to our slide, well, this dispatcher is basically of 4 types. The first one is the default, then we have unconfined, then main, then IO. Well, just now we saw these two dispatchers, right? But this main dispatcher basically works on the UI objects, and this IO dispatcher is used for IO operations. So we are not going to discuss them right now. We will discuss these two dispatchers in a separate Android tutorial, because it is in Android where we will use UI components and do some IO operations. So for now, don't worry much about them. So for the dispatcher, just remember it is the dispatcher which decides on which thread your coroutine will execute. Fine. Now next we have this job object, which we have already explored in our previous videos. So I guess no need to discuss anything about this right now. Next, what about this coroutine names? Well, you can assign a name to your coroutine and even combine two coroutine contexts together. And also by assigning names to your coroutine, you can debug your coroutine, right?
I hope you had a wonderful journey watching this course. I am glad you have made it till the end of this course. So how was the course? Please let me know in the comment box below. And please like this video, share this video and support my work in any way possible you can. This is Shreyang Siddharth signing off and thanks for watching and have a nice day. Bye.